Hello everyone, my name is Neha and I done internship on embedded system at Emertexi. In that internship, I have successfully completed a project that is microwave oven. So let's discuss the content of my today's presentation. These are the contents of my today's presentation. Introduction of embedded system, also embedded C, then microcontroller and microprocessor, requirements of my project, peripherals in PICSIM labs and PIC16F877A microcontrollers, CLCD interface, matrix keypad, interrupt service routine, timer, and then demo of my project implementation. So now discuss the topics which I learned during the internship. First one is that introduction to C. In that I learned conditional loops, operators, arrays and pointers, also storage classes. Then introduction to embedded system, microcontroller and microprocessor, software like MPLAB ID, XC8 and PICSIMLab. Then peripherals of PIC16F877A. PIC16F877A is a microcontroller which I have used in my project. Then interfacing of peripherals like buzzers, LCDs and all. Then micro one project. Now discuss one by one briefly. What is embedded system? Embedded system is a combination of any hardware and software which is intended to do a specific task. In my project, it works as a command device. It has four types, that is stand-alone system, real-time system, network system and mobile system. Embedded system is defined other words like it is an electronic or electromechanical device which consists hardware and software which perform specific function or set of function repeatedly. As we know, there are two types of system. First one is general purpose system and second one is embedded system. A general purpose system is used to perform a large number of tasks, whereas embedded system is used to perform a specific task, because embedded system may or may not contain the operating system, but general purpose system is must contain the operating system. Also, application of embedded system are specific, whereas application of general purpose system are specific or general. Next, we will discuss the difference between microcontroller and microprocessor. Microprocessor contains only CPU, whereas microcontroller contains CPU, memory, input, output, all integrated into one chip. Microprocessor used in a personal computers, whereas microcontroller are used in a embedded system. A microprocessor based on only human model, whereas microcontroller based on hardware architecture. It is complicated, means microprocessor is complicated and expensive with a large number of instructions to process, whereas microcontroller is less expensive and straightforward with fewer instructions to process. A microcontroller is essentially just a central processing unit on a single chip focused on high processing power and requiring external memory and peripherals to function, while a microcontroller integrates the CPU, memory and input-output ports all onto one chip, making it a self-contained computing unit ideal for embedded system with specific control tasks. In simple terms, a microprocessor is the brain of a computer, while a microcontroller is the brain of a small dedicated device like a washing machine or thermostat, also digital camera. Next, we will discuss the requirement of our project. First requirement is embedded C. Embedded C is a specialized version of the C programming language designed specifically for developing software on embedded system, which is a small computer system with dedicated functions allowing programmers to directly control hardware components like sensors and actuators by utilizing features like hardware addressing and memory management tailored to the limitations of microcontroller, making it ideal for application with big power and memory constraints. Essentially, it's an extension of C that provides direct access to low-level hardware functionalities within embedded system. Next is PIXIM Lab. PIXIM Lab is a real-time emulator that emulates hardware to test and program microcontrollers. Then it supports many microcontrollers and devices including LEDs, push buttons and Ethernet chips. In the microwave project, it supports the PIC16F877A microcontroller and devices like LEDs, buzzers and matrix keypad also. Then comes MPLAB XID. MPLAB XID is a software program that helps users develop applications for microchip microcontrollers and digital signal controllers. It is also called editor, project manager and simulator. It compiles for C, C++, BASIC and other languages are available separately. Then come MPLAB XC8 compiler. It is a C compiler specifically designed by Microchip Technology to compile code for 8-bit PIC microcontrollers. It will allowing developers to write C programs that are then translated into machine code optimized for the target PIC chips architecture. It is integrated within the MPLAB XID and offers features like different optimization levels, device-specific configuration options, and access to the PIC special function register through pragmas in the code. Next, we will discuss the architecture of PIXIMLab. PIXIMLab contains the LEDs, buzzer, digital keypad, matrix keypad, and IS-232, GPIO, EEPROM, temperature sensor. Let's discuss one by one briefly. First is CLCD interface. CLCD interface is a character liquid crystal display. It has two types of display. Basically, it has three types like 16:1, 16:2 and 16:4. In 16:1, LCD can display one line of 16 characters. Same as in 16:2, LCD can display two lines of 16 characters. Whereas 16:4, LCD can display four lines in 16 characters. It is used to display all ASCII characters and symbols. It has a totally 16 interfacing lines. D0 to D7 are data lines. It has a built-in controller that can execute the instruction and data. As you show here, this is the LCD. Next comes the matrix keypad. It is a small compact input device. It accesses users' input and proceed by microcontroller. Also, it is a key press identification, can be explained in a step-by-step manner, which invokes the software. First, we input high on row pins. When a key is pressed, the corresponding row and column gets shorted. In the second step, the software scans the pins connected to the columns. This is a keypad in which number of switches are connected. RB to RB acts as the input, whereas RD0 to RD3 acts as output for the microcontroller. In this project, it is used to select cooking modes and set the time, etc. Next, interrupt service routine. Interrupt service routine. It is a interrupt is a communicating process set up in a microprocessor or a microcontroller in which an internal or external device requests the MP or MC to stop the processing. An interrupt service routine is a software outline that hardware invokes in response to an interrupt. It handles the request and sends it to CPU, interrupting the active process. When the ISR is complete, process is resumed. It is a software also that invokes in a response to an interrupt. A basic example of interrupt service routine is that a routine that handles keyboard event such as pressing of releasing a key. Then next is timers. A timer is a specialized type of clock which is used to measure time intervals. It maintains the timing of operation in sync with the system clock or an external clock, used to count cycles and perform a particular action at a specified moment or optionally start an interrupt cycle. The PIC16F877A basically has three timer modules. Timer module terminals are also multiplexed with other functions for handling alternate functions. It has three timer modules, timer 0, timer 1 and timer 2. In this project, timer 2 module is used. Next, project demo is there. Let's start to implement the microwave oven project. As you show here, there are header file, source file. In that main.c is there, main.h is there. So this is my whole code. In that I have defined timers, buzzers and all the peripherals that is required to my project. Now I build my project. Yes, as you see here, output is successfully built. Now next task is that I have to load into the board, that is PicGenius. In the PicGenius board, I have to load my file. I will load the file which I saved in my PC. Just a minute, it will be loaded. As you show here, there are 4 modes showing: micro mode, green mode, convection mode, start mode. Yes, now we will see one by one. First, in the micro mode, how microwave oven is operate. Let's start to press a 1. Here timer is there, in which we have to set a time. I will set a 45 seconds. Let's start. As is shown here, fan is running and also output is showing here. If you want to pause or stop, there are 5 or 6 buttons. Yeah, check once again. Randomly I give the time as 45 seconds and start the operation. Now fan is running. If you want to pause, we will press 5 and whole operation will be paused. After that, if you want to start or resume our operation, press 4. It will be start again. Now let's start with the second mode, that is grill mode. Here timer is there. I will define a timing as 12 seconds and start my operation. Yes. The project's success is attributed to the comprehensive guidance and resource provided by the Emertaxi Foundation. Their expert instructors and well-structured training programs facilitated my learning and helped me overcome challenges. Thank you once again.